Hello, everyone. Welcome. My name is Beth Mahaffey. Today we're going to be talking about astronomy as part of the New Moon series. The New Moon series contains 5 parts. The first one was the New Moon significance. The second one is the historical practice and debate of the new moon. Number 4 is calendars, including the Metonic cycle. And part 5 is a calendar for Yahweh's people. The goals of this series are to teach the significance of the new moon, to fully educate Yahweh's people who desire to walk in obedience to his commandments regarding the new moon's role in observing the feasts of Yahweh, to introduce and address the debate over conjunction versus new crescent moon, to equip Yahweh's people with the astronomical knowledge necessary to evaluate subject matter regarding the new moon and the various proposed calendars currently being used by his people, to propose a calendar that Yahweh's people worldwide can follow without reliance on other assemblies, and finally to encourage unity and observance of holy convocations around the world. Without further ado, let's get started. As we saw in the previous presentation, groups define new moon differently. Astronomers define the new moon as conjunction. Therefore, anytime you see new moon in this particular presentation, think conjunction unless otherwise indicated. Keep in mind that in the previous presentation, I supported the definition of a new crescent moon as being the first day of each month so that the feasts can be celebrated in their appointed times. Genesis 1:14 through 18. Then God said, "Let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons and for days and years. And let them be for lights in the firmament of the heavens to give light on the earth." And it was so. Verse 14 indicates that the lights in the sky are the major factors that determine the signs, timing of the Moedim, which are seasons and feasts of Yahweh, and calendar reckoning. All other factors should be considered secondary. Beginning with verse 16. Then God made 2 great lights, the greater light, which is the sun, to rule the day, and the lesser light, which is the moon, to rule the night. He made the stars also. God set them in the firmament of the heavens to give light on the earth, and to rule over the day and over the night, and to divide the light from the darkness. And God saw that it was good. Notice how this chiasm points to verse 17, showing the purpose of giving light on earth. Is this not what Yeshua did when he came to earth? As you can see, the sun, moon, and stars have a purpose that we often overlook or take for granted. As we move forward, let us also keep this verse in mind. Deuteronomy 4:19 says, "And take heed lest you lift your eyes to heaven, and when you see the sun, the moon, and the stars, all the hosts of heaven, you feel driven to worship them and serve them, which the Lord your God has given to all the peoples under the whole heaven as a heritage." We are to avoid astrology, yet we must learn and understand astronomy in order to evaluate calendars. The key difference is that astrology involves worship of the celestial creation and/or is used to predict the future affairs of people, and both are forbidden in Scripture. Astronomy is a study of the celestial bodies and how they operate together. Before we can properly evaluate calendars for the purpose of keeping Yahweh's feasts, we need to understand some basic astronomy. This presentation will allow us to do just that. In this photo, the Earth is tilted to the right about 23 degrees from its upright position. This photo depicts the Earth's movement around the sun within the celestial field. The Earth is often described as having an imaginary celestial field around it. This makes it easier to describe what's happening around it. A 23.4 degree tilt of the Earth is maintained as it orbits the sun. In this same photo, you can think of the Earth as a fried egg with a blue yolk and the white part of the egg forming the equatorial plane. We can imagine an invisible spatula lifting up this egg about 24 degrees, thereby creating the ecliptic plane. We can imagine a spoonful of butter off to the side representing the sun on top of the white part of the fried egg next to its blue yolk. The Earth's orbit around the sun is elliptical and counterclockwise. This orbit takes place within what is called the ecliptic plane. As the Earth orbits the sun, the Earth is spinning on its imaginary tilted celestial pole. One revolution of the Earth on its celestial pole takes 24 hours. This causes day when one side of the Earth is facing the sun, and it causes night when the side of the Earth is no longer facing the sun. The previous photo was with the Earth and its celestial pole tilted 23.5 degrees to the right. The next picture shows it turned so that the celestial pole stands upright, causing the ecliptic plane to appear tilted upward by 23.5 degrees. In addition, we will add grid lines that are somewhat comparable to the Earth's longitude, which we would call X on a graph, and latitude, which we would call Y on a graph. Locations on the celestial field are measured by coordinates called right ascension, which would be the X coordinate, and declination, which would be the Y coordinate. They are measured from the first point of Aries, which is where the March equinox is. This is the XY position of 0, 0. Right ascension is measured in hours, but it can be measured in degrees. And of course, there would be a total of 24 hours or 360 degrees of right ascension. Declination is measured in degrees from the equator. You would have positive 90 degrees from the equator up toward the north celestial pole, and you would have negative 90 degrees going down below the equator toward the south celestial pole. A conjunction occurs anytime two solar system bodies, such as the moon and the sun, have the same right ascension. If two bodies, like the sun and moon, have a similar appearance in size due to their distance from each other, the conjunction is called an eclipse. Now, if we were to remove those grid lines of the celestial field, we can simply see the equatorial plane and the ecliptic plane as we see in this picture. From our position on Earth, the sun seems to go around the Earth. However, you need to remember that the Earth really goes around the sun. The seasons are not determined by our distance from the sun. Instead, they are determined by the degree of the sun's direct heat and the tilt of the axis of the Earth's rotation. In this picture, we can still see our blue fried egg where the Earth or egg yolk is in the center and the white part of the egg forms the equatorial plane. The equinoxes take place when the apparent path of the sun in the ecliptic plane crosses over the equatorial plane. The March equinox is the beginning point of the year. The June solstice takes place when the sun reaches its peak of 23.5 degrees above the equatorial plane. The opposite is true for the December solstice. In this photo, I've kind of modified it a little bit so that we can see exactly where the Earth's axis is in relation to the equatorial plane, which is perpendicular to that, and then see that the ecliptic is about 23.5 degrees higher on the right than it is on the left. And if we were to trace the path of the sun through the ecliptic plane from the perspective of the Earth, it would create a full sine wave from and to the March equinox. The seasons experienced in the southern hemisphere are opposite of those experienced in the northern hemisphere. and not everyone recognizes the seasons of the year based on the astronomical timings of the astronomical equinoxes and solstices. The 4 seasons can be reckoned in several ways. One way is meteorologically by temperature, and usually these are in 3-month groupings. When I was serving as a missionary in Ukraine, this is how they determined the seasons. For example, spring would be March, April, and May. Summer would be June, July, and August. Fall would be September, October, and November. And winter would be December, January, and February. Astronomically, by the sun's transit through the equinoxes is another way that the seasons can be reckoned. The equinoxes usually take place around March 20th and September 22nd. The solstices take place around June 21st and December 21st. Another method is by solar timing, in which the equinoxes and solstices mark the midpoints of the seasons instead of their beginnings. You may have heard of a midsummer or mid-spring or midwinter, as a phrase to describe the seasons, and that's where that comes from. Another method is a 6-season calendar reckoning. Another is polar day and night. At the Arctic Circle and Antarctic Circle, there will be a period in the summer when the sun does not set, and there's a period in the winter when the sun does not rise. Non-calendar based reckoning, which is ecological in nature, is another method. This is when we look at things like daily floral or animal events and how they change. During the time when Israel sighted the new crescent moon, they were primarily using the equinox to determine spring. However, they also considered ecological factors such as floral and animal events for other practical reasons when determining the month of Nisan. We will look at those factors in the next presentation of this series. These ecological factors are not considered by the Hillel II calendar, which is a fixed calculated calendar. Kiddush HaChodesh, chapter 1, says, "The years we follow are solar years, as implied by Deuteronomy 16:1. Keep the month of spring." Sanhedrin 13b, cited by the Rambam, chapter 4, Halakha 1, explains that this verse is a charge to arrange the calendar so that the vernal equinox always falls in the month of Nisan. Note that the term Aviv is translated here as spring, which is the modern translation of Aviv today. Like the Earth, the moon spins on its own axis. The moon's orbit around the Earth is counterclockwise and elliptical. The moon takes about 29.5 days to orbit the Earth. The moon's orbit tilts about 5 degrees above and below the ecliptic plane, and this affects how we see the moon in its different phases. If you get the chance to see the PDF version of this, you'll note that there is a YouTube video that's at the end of the presentation. I suggest you take time to look at that because there's a woman that actually demonstrates how this takes place. She does this with a lamp and a styrofoam ball that is on a pencil, and she herself acts as the Earth, whereas the ball that she's holding acts as the moon. And as she turns with the ball at a certain distance from her in a complete 360-degree turn, you can actually see the moon phases on the styrofoam ball. It's just absolutely fascinating, so you can get an idea how it really works. It takes about 7.4 days for the moon to move through one of the 4 main lunar phases. This can vary a bit due to lunar apogee when it's slower and perigee when it's faster. Perigee is the point of least distance for any satellite, including the moon orbiting the Earth. This is where the supermoon is seen from Earth. I'm sure you've gone out and seen a full moon and thought, wow, that looks really big. And that's when it's at supermoon. Apogee is the point of greatest distance for any satellite, including the moon, orbiting the Earth. and this is where the micromoon is seen from the Earth. And there are times when you go out and you see the new moon, and that moon seems a lot smaller than you think it should, and that's because it's a micromoon. The time it takes to get between moon conjunctions can be 29 or 30 days, and the time that it takes to get from conjunction to full moon can be either 14, 15, or 16 days. As a result of this variation, the feasts that take place on the 15th of the lunar month may or may not actually take place on the actual full moon, although the moon will appear to be full. There are 2 nodes where the moon's orbit crosses over the ecliptic. At those points or nodes of the moon's orbit, an eclipse can take place if the Earth's moon and the sun are in close alignment. The sun shines on one half of the moon at all times, but because of its changing position around the Earth during its orbit, we see different phases of the moon. And this is what I was talking about when I suggested seeing this YouTube video that is at the end of the presentation. And if you take the time to view this, it's good if you can start it at the 56-second mark. Normally, toward the end of each month, the moon becomes hidden and can't be seen for approximately 3 days. The Jews expected to see the new moon on the 30th night. Darkness takes place approximately 1 day before the complete conjunction of the sun during full conjunction and approximately 1 day after conjunction. This is approximately a total of 3 days. Afterwards, the new crescent moon can be sighted in the west at sunset. We often talk of conjunction as the period of the dark moon that lasts approximately 3 days. This is okay, but actually conjunction is only a brief moment in time when the percent of illumination of the moon is at its lowest point. Conjunction is also considered to be the brief point in time in which the waning crescent moon transitions to the waxing crescent moon. The opposite of conjunction is full moon, which is when the percent of illumination of the moon is at its greatest point, although we do not perceive the exact moment that it's at its greatest point. In this photo, conjunction of the moon is not displayed. The northern hemisphere would see the phases moving from right to left. New waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third or last quarter, and waning crescent. The same general phases of the moon can be seen at the same time all over the world. However, people in the southern hemisphere see the phases in a different manner from those in the northern hemisphere. The northern hemisphere sees the new crescent on the right side of the moon, and by the first quarter it looks like a D. The southern hemisphere sees the new crescent on the left so that it looks like a C. The different phases of the moon, such as conjunction or full moon, do not reliably take place on the same day of the week each month. The only thing reliable is that the moon moves through each phase of its cycle over a 29 to 30-day period. And this is a very important concept for us to remember when evaluating various calendars. The following data was collected using a virtual planetarium program called Stellarium, which calculates the position of the sun, moon, stars, and planets. Based upon dates entered by the user, other dates can be calculated as well, such as moon illumination. Military time is in parentheses. What I'd like to do is draw your attention to the red areas there. On the second line down for April 2018, you can see that the time of conjunction is such that the percent of illumination is at 0.2%. The sunset is 1 day after conjunction at 1.2%, and sunset 2 days after conjunction 4.7%. We have another red line in July 2018 that is similar to this. And why I'm pointing out the red is because on these days, the conjunction occurs after sunset. However, one of the other things that I want you to see in this chart is how the sun is, percent illumination is lowest at the time of conjunction compared to when the sunset is before conjunction, the first day after conjunction, and 2 days after conjunction. At the time of conjunction, the percent of illumination does not always go down to 0. Sometimes it's 0.1 or 0.2, somewhere around there. So it's not always 0, but it is at its lowest point. We see something similar to that in this next slide. And basically, these two slides show you what it is for 2018 through 2019 for the Hebrew year. Since the point of lowest moon illumination occurs during conjunction, it represents the death of the moon cycle, not its birth. The Hebrew word for birth is malad, and that's what the Jews call conjunction. But really, like I said, the illumination of the moon is at its lowest point, so it really should be the death, not the birth of the moon. Only after the lowest point of illumination is reached does the illumination of the moon begin to increase, and that's why I believe the new crescent moon represents its birth. According to earthsky.org and skyandtelescope.com, a reliable record of the youngest crescent moon seen with the unaided eye was achieved by Stephen James O'Meara in May 1990. He saw it 15 hours and 32 minutes after the moment of conjunction. In 1871, there were two other records. One was 15 hours and 24 minutes, and the other was around 15 hours. Astronomers recognize 88 constellations in the sky. Some constellations are specific for either the northern or the southern hemisphere. These constellations are circumpolar or positioned around one of the Earth's poles. In this photo, I've kind of indicated an area where the circumpolar constellations are in the northern hemisphere and in the southern hemisphere. People who live in the northern hemisphere never see the circumpolar constellations of the southern hemisphere from where they live. And those in the southern hemisphere never see the circumpolar constellations of the northern hemisphere from where they live. The only way you're going to see these constellations is to go on a trip and specifically look to see them. Non-circumpolar constellations are positioned between the circumpolar constellations of the northern and southern hemispheres. And I've tried to indicate that on this picture, which is the same one we saw before. And this is where the zodiac belt is, or the Mazarot are. Here is another picture with a different perspective. The non-circumpolar constellations shift with the seasons. These constellations are visible or invisible as the seasons of the year shift. And again, these are the constellations of the zodiac, or the Mazarot, that are located in a band that's about 20 degrees wide, the center of which is the ecliptic plane. Now, in this picture, we also see that the Earth is circling the sun. And depending on where we are during the year, from our perspective on Earth, if we're looking past the sun or through the sun, and if we knew how to identify our constellations, we would say that the sun is in a particular position within the zodiac. And so if we were, where the Earth was near Virgo, if you're looking at the lower end, and looking through the sun above, we are looking at the sun as it's traveling through Pisces. and that's where it would be around March 21st or March 20th. From our position on the Earth, the sun appears to take about a year to pass through all of the constellations. And the moon appears to pass through all of them in a 24-hour day. The movements of the sun, moon, and stars through the zodiac are similar to a clock. The moon moves through the entire zodiac in a day. That's 24 hours. And it parallels the second hand of a clock. In addition, the moon orbits the Earth in a month, and we see a new zodiac sign at the beginning of each month. And the time it takes to do this is 29 to 30 days, and it's comparable to the minute hand on a clock. The sun moves through the zodiac in a year, or 365 days, and it is comparable to the hour hand of a clock. Now, because of the elliptical orbit, the clock can run a bit slow or fast as it moves through the constellations. And we will see how this impacts the calendar for God's people. Now, there is a third movement of the Earth that we need to understand. As the Earth is spinning on its axis at a 23.4 degree angle, its axis is moving in a small circle like a top. If you've ever spun a top and watched it slow down, this is when you start to see the top of the top wobble, kind of in a circular motion, back and forth, kind of like this. This wobbling circular motion is known as precession. To make one small complete circle, which is 360 degree rotation on the celestial field, it takes about 25,920 years. In this next photo, we're looking at the North Pole. And as we're looking down on this North Pole, the circle in red is the circle of precession that is made by the Earth's axis as it's precessing. We also have on this photo some northern circumpolar stars labeled there, and the non-circumpolar constellations of Taurus, Aries, Pisces, and Aquarius are marked according to their right ascensions and are located actually much lower on the celestial field. The North Pole star will gradually change over time so that a different star becomes the North Pole star. Right now it's Polaris. It can also be Alpha Cephei, Delta Cygni, Vega, and Thuban. At the time that the Israelites were in Egypt, the North Star was Thuban. Because of the axis on which the Earth is precessing, the background of the stars on the celestial field appear to change about 1 degree every 72 years, and this affects the position of the equinoxes and the solstices. Around 3000 to 4000 BCE, the sun was in Taurus during the vernal equinox, and around 1000 BCE, the sun was in Aries. The sun is currently in Pisces during the equinox, and by 3000 Common Era, the sun will be in Aquarius during the equinox. These time periods or positions are referred to as ages. The constellations seem to have two functions. They are similar to the numbers on a watch face to count how many hours of the day, days of the month, or month of the year. They are also similar to the numbers on the bezel or outer ring of a watch to mark the March equinox and to count the ages passing due to precession. Around 150 Common Era, Claudius Ptolemy first mapped the constellations, and at that time the constellation Aries was located in the same position as the March equinox, which is also known as the first point of Aries. With this in mind, let's read this quote from Josephus. In the month of Xanthicus, which is by us called Nisan, and is the beginning of our year, on the 14th day of the lunar month, when the sun is in Aries, for in this month it was that we were delivered from bondage under the Egyptians. The law ordained that we should every year slay that sacrifice which I before told you we slew when we came out of Egypt, and which was called the Passover. And so we do celebrate this Passover in companies, leaving nothing of what we sacrificed till the day following. So, based on Josephus' testimony, we know that the sun was passing through Aries at that point in time. Here's another quote from Philo this time. The spring equinox in the constellation of Aries and the autumnal one in Libra gives the most evident demonstration possible of the divine dignity of the number 7. Because of precession, the equinoxes have moved. The first point of Aries is now in Pisces. The northern hemisphere, or the vernal equinox, would take place in the spring. For the southern hemisphere, this is when the autumnal equinox is. Of course, both of these are around March 20th. The first point of Libra is now in Virgo. For the northern hemisphere, this is the autumnal equinox. The southern hemisphere, this is the vernal or spring equinox, and it takes place around September 22nd. One of the reasons that in these presentations I keep repeating March equinox is because it makes it a little easier when talking about things, because the northern hemisphere is celebrating a different season compared to the southern hemisphere. So you'll hear me say March equinox or September equinox unless I'm quoting something. So just kind of bear that in mind. In addition, because of precession, the solstices have also moved. The Tropic of Cancer is now in Gemini. This in the northern hemisphere is summer, southern hemisphere is winter, and this takes place around June 21st. The Tropic of Capricorn is now in Sagittarius. Of course, this is when the northern hemisphere has winter and the southern hemisphere has summer, and it takes place around December 22nd. Back in biblical days, the astronomical constellations were as follows. Nisan was when the sun was in Aries. Iyar was when the sun was in Taurus. Sivan when the sun was in Gemini. Tammuz when it was in Cancer. Av when it was in Leo. Elul when it was in Virgo. Tishrei when it was in Libra. Cheshvan when it was in Scorpio. Kislev when the sun was in Sagittarius, Tevet when it was in Capricorn, Shavat when it was in Aquarius, and Adar when it was in Pisces. And again, the sun is no longer in these positions. As we evaluate different calendars, we must bear in mind the effects of precession on perceived constellation positions when looking at ancient texts to determine spring or aviv. Otherwise, we'll be in error. So, in other words, the sun is no longer in Aries, in Nisan, as it was written in these texts, and we must use the sun's new equinox position as a guide for determining aviv, and it is in Pisces for spring. As previously mentioned, a solar year is the time it takes for the Earth to orbit the sun, which is about 365 days. During this time, it appears to us from Earth that the sun is passing through all the constellations in a year. Astronomers in ancient times were aware of the location of the sun among the constellations. One of the reasons that I'm putting this picture here is to give you an idea of what the conjunction looks like. You have the sun in the background with a little black dot on it, and that little black dot is the moon. The actual moment of conjunction is the same all over the world. It just seems different because of the difference in time zones. Of course, observance of the new moon would be affected by the daytime and or the nighttime hours after conjunction. The time of sunset is different all over the world. The condition of day and night also limits observing the new moon within a 24-hour period worldwide. Okay, in this chart, I have listed conjunction dates and times, sunset dates and times, and new moon dates for 6 locations across the globe. If you look at the second row where we have conjunction time, the times look different, but they're really not. If we look at London, England, this is the Greenwich Mean Time, where UTC is 0. As we move to the left, such as Miami, Florida, or to Anchorage, Alaska, we can see that there is a decrease in the number of hours because of this time zone differences. And if we were to move to the right, such as Jerusalem, Israel, or New Delhi, India, or Brisbane, Australia, you can see how many hours are added to compensate for the time zones. And when you subtract out or add those hours, you can see that conjunction truly is happening at the same time all over the world. The problem that we have is that there's 24 hours in a day, there's day on one side of the earth, and there's night on the other. And so what we're going to find is that depending on the time of sunset, which determines the beginning of a new day, we're going to have our new moon dates be different from one side of the earth to the other. And it'll only be off by one day, but it'll be different. This picture is of a map with stars indicating the locations of the previous chart that we looked at, so you can see where they are located. I've also tried to indicate the time zone hours as we move across on the bottom to make them larger so that you can see them. In our example, the date for the new moon was different in Israel than it was in America. The date for the new moon can change at any point on the map. It doesn't have to take place at Greenwich Mean Time. It doesn't have to take place in Israel. It can take place at any stage along the way. Hopefully, this astronomy information will have prepared you to critically analyze different calendars and help you decide what to look for in a calendar so that the feasts of Yahweh can be held in their appointed times. Be careful not to be quick to make assumptions about what the scriptures say and what you've been told. Please draw your conclusions carefully. The next presentation in the New Moon series is calendars, including the Metonic cycle. Please come back and make sure that you see them. Thank you.